is used to find for discrete sequence. And suppose Fn is any function, then Z transform of Fn is equal to summation of n is equal to minus infinity to infinity Fn Z minus n. Transform is basically used for discrete sequence, and if Fn is any function, then Z Fn is equal to summation of n is equal to minus infinity to infinity Fn Z minus n. And if n is greater than equal to 0, then our definition converts in the form Z of Fn is equal to summation n greater than equal to 0 to infinity Fn Z minus n. So when we are putting some values of Fn, we can get special result. So first one, I am going to start. If Fn is equal to a raised to n. If Fn is equal to a raised to n, then Z of an according to the formula, it is n greater than equal to 0. Why? Because we are talking about n greater than equal to 0. Up to infinity, a raised to n, Z of minus n. Now for finding the answer, what we have to do? First thing, convert it in the positive power and take it common as like n greater than equal to 0 to infinity an 1 upon z. As a or z are having the same power, we can write it as a upon z raised to n greater than equal to 0 to infinity. When we expand it, then what we get? A upon z raised to 0, a upon z raised to 1 and a upon z raised to 2, so on. How can we expand it? We are putting first n is equal to 0, n is equal to 1, 2. As we are having the summation sign, so we are using plus sign is here. It is converted in 1 plus a upon z square and so on. Finally, this is the binomial expansion and can be written as 1 minus a upon z inverse, because 1 minus x inverse is equal to 1 plus x square and so on, binomial expansion formula. So in place of x, we are putting a upon z. After simplifying, 1 upon a minus z upon z minus a is the answer of a raised to n z transform. Second function we are going to take here when an is changed and become n. So for second function, it is n. Similarly, z of Fn, it means in place of Fn we are putting n summation n greater than equal to 0 to infinity and z minus n. Again, z minus n convert in positivity and 1 upon z raised to n. When we expand it and putting 0, 1, 2 and so on, 0, 1 upon z 0, 1 upon z1, 2 1 upon z square, 3 1 upon z cube and so on. So multiply by 0, anything is 0, plus 1 upon z, 2 1 upon z square, 3 1 upon z cube and so on. When we take the common 1 upon z from this term, 0 is nothing, so taking common 1 upon z, it is 1 plus 2 1 upon z, 3 1 upon z square and so on. So when we see the binomial expansion formula 1 minus x raised to minus 2, it is 1 plus 2x, 3x square and so on. By comparing this, 2 and what we can take? X is equal to 1 upon z. X is equal to 1 upon z, and then binomial expansion formula applying minus 2. 1 upon z, z upon z minus 1 positive power. Just convert it in positive power by taking the LCM, like 1 upon z, z minus 1 upon z minus 2, and minus 2 को positive कर रहे हैं, so we are reciprocal the middle term. Now it has become by cancelling z in 1 z, we are getting the answer z upon z minus 1 square. So these two are very important functions, and we can directly use as a formula z of fn is equal to z upon z minus 1 square.